Good eve- Good evening, everybody. Am I audible? Hello.
Yes, sir.
Okay. So, hi. Good evening. Myself, Oniket Jana. I am doing my PhD in IIT Jodhpur in interdisciplinary research program. So, today I welcome you, everybody, in the doubt clearing class of NPTEL Stereochemistry. Hope this session will help you in better understanding the subject. Okay. So let's start. Today we will mainly focus on the assignment one. Hope you have attempted the assignment one. Have you tried to solve the assignment one?
Yes, sir.
Okay, so it will be a total interactive session. We will discuss and try to solve the problem, whatever you have faced. I will try my best to solve your problem. So let's start. So I am opening a PowerPoint which I have done to solve the assignment one. So we will discuss on that points. Okay. Is there any query or question? Anything anybody wants to say?
Yes, sir.
Yes.
Actually, I wanted to say that sir I will learn only about one chiral carbon to convert it to Fisher projection formula from the wedge dash, right? But
Hmm.
what about if there are two or more?
Okay, you want to learn that converting means flying wedge to Fisher formula where there is more than one carbon, right?
Yes, yes, yes.
Discuss in the due course. Okay.
Okay.
Okay, so let's start solving assignment one. Is that okay? Everybody is okay with that? Please respond. Otherwise,
Yes,
I
sir. Yes,
cannot
sir. Please,
understand.
please continue.
Okay. Yeah, yeah. Everybody, please respond. And whenever you have a problem, please let me know. Okay.
Okay.
Okay. So, is my screen visible?
Yes, sir.
Okay.
Yes, sir.
So, let's start with the first problem. Have you solved this? What will be the answer? What do you think?
Sir,
The
option
first.
B.
Yes, because in this case, whole bonding is different.
Yes, absolutely right. Here, enantiomer is the thing that which is non-superimposable mirror image. Okay, and diastereomer is not a mirror image, but here the bonding connectivity is completely different, right? So here, it is the constitutional isomer, right? The two bonding connectivity is different in these two molecules. Okay.
Yes, sir. Yes.
Okay. If
Yes,
you
sir.
anybody has
Got it.
any issue, any problem, just let me know. Okay, please. Somebody. Okay. Then coming to the next question. Okay, this one. Question number 2. So what is the answer?
Sir, 4.
Yes, 4. So if we this one, this one, this one, and this one. Okay, so 4 stereogenic centers are there, right?
Yes, sir.
So do you know what is how can we determine the stereogenic center? Means what is the shortcut formula? How we can
सर एक बार बता दीजिए कैसे निकालेंगे?
sure, sure. So stereogenic center are there in the 4 stereogenic center. So if usually the carbon has the 4 ligand, right? Usually the valency is 4, carbon has the 4 valency. So if we exchange the 2 ligands attached to the atom, spatially, and the new stereoisomer is formed, okay, so then we can say it a stereogenic center. A new stereoisomer has to be formed after the exchange of the two ligands, any two ligands. Okay. So that will be we call the stereogenic center. In this way, you can determine how it is stereogenic center, how many stereogenic center are there in the molecule. Okay. Is there any problem?
Excuse me, sir.
Yes, yes.
Sir, while solving problems which includes more complicated molecules, even if we interchange any two ligands, it's not very, easy to determine whether or not it will form a new stereoisomer. So how do we do with complicated molecules?
Actually, we have not gone through the description, right? R and S. Okay. So if we do this like this center, if we do the description like R, S nomenclature, So if we exchange the ligands and if it changes from R to S, then we can say it a stereogenic center. Okay. Like here the chloro is, you can see, is the equatorial form. Okay. So if we exchange, there is a hydrogen in the axial position. So if we exchange that chloro in the axial position and hydrogen in the equatorial position, then the whole configuration, the optical rotation of that center will be changed. Okay, so in this way, we can determine whether a particular center is stereogenic or not.
Okay, sir, it's clear, sir.
Okay, okay. Okay, the next question. Okay, then option 3, sorry, question 3, which one is the correct statement? What do you think? Which is one is the correct statement? Hello?
The answer is also already given. That's why.
Okay, just it is an interactive session. If you have any
Okay.
problem or anything, you think that it
Yes,
is a
it's C1 is always there because when we rotate
yes,
it by 360 degree, it is always
yes,
identical.
yes, absolutely. All other three options are not correct. Like S2 and I are the identical
They are
operation.
identical, right?
Yes, all dissymmetric molecule are always asymmetric. It is not
No,
right.
because all asymmetric are dissymmetric.
Yes, the reverse is the true. And D, an asymmetric molecule is not always chiral, it is always chiral. So only C1 means C is the correct option. Okay.
Yes.
Okay. So then coming to, if anybody has any problem or any confusion, please stop me and we will discuss on that question. Okay.
Sure, sir. Sure.
Okay. Then question number 4. What is the answer? Means don't look at the answer written here. You just say from yourself. Okay. You have tried or any difficulties you have faced.
Sir, how we find that how many enantiomers just by rotating the concept or any different concept is used there?
No, I will discuss that. Okay. So here, as you can see here, that this molecule, when this molecule can be divided into two equal parts, right? Here, if we imagine a imaginary plane according to this line, so there it can be divided into two equal halves, right?
Yes, sir.
So when a molecule can be divided and it has even number of chiral center, here how many chiral center we have? Two chiral center, absolutely right. Then and 2 is a even number, so the formula says that 2 to the power n minus 1 number of the optically active compound is there. So n equals to 2, 2 minus 1, that is 2 to the power 1. So 2 enantiomer, that is optically active isomer, it has.
Now let us take example, sir. If molecule which cannot be divided into equal halves.
Okay, then if cannot be divided into equal halves, then the number of the stereoisomer is 2 to the power n.
2 raised to power n. Okay.
2 to the power n. Yes.
In both cases, even number or odd number, is it?
Yes. If
Okay.
it cannot be divided into two equal halves, so it is the number is 2 to the power n.
Okay.
And
And
the
if it is
all
divided, then 2 raised to
and
power
it
n
is
minus
it
1.
is it if it is divided into two equal halves and it has the even number, then optically active compound is given by 2 to the power n minus 1 and optically inactive isomer is given by 2 to the power n minus 2 by 2. Okay. when even number of chiral center is there.
Okay,
Can
n
you
by 2 minus 1 means 2 raised to power n
yes,
by 2 minus 1.
yes. And
Oh,
if it is had odd number of the stereo, can you see what I am writing in the slide?
yes, sir.
Okay. If it is odd, okay, just for example, I am saying the formula, you can note down. Then 2 to the power n minus 1 minus 2 to the power n minus 1 by 2. It is the active form. Okay, and inactive form is given by 2 to the power n minus 1 by 2. Is that clear?
Wait, sir. Means first one is 2 raised to power n minus 1 if it is even, right?
It is even if it is as even number of the chiral center. Okay,
Or
then it is
and
the
these are
active. It is
okay.
active number of isomer. It is optically inactive.
Means
Okay.
meso.
Yes, it can be meso, but it is optically inactive.
Okay.
Not
And
always meso, not
if they are
necessarily.
odd, then it is 2
2 to the
raised to
power n minus 1 minus 2 to the power n minus. Can you see that this is the optically inactive number? So this is the total number 2 to the power n minus 1, and we are subtracting the inactive number. So we are getting the active number, and it is the inactive number of isomer.
okay.
Okay.
Thank you.
Okay.
So, sir, as it is recorded, so you
Hmm.
can send the link of this video afterwards.
Yes. It is. It will be uploaded in the YouTube channel. So okay.
Okay, thank you
So
so much.
and from NPTEL site, it will get you will get the link of that channel. Okay.
Sure, sir. Thank you.
Okay. Is anybody has any other doubt? Anything?
Sir, excuse me, sir.
Yes.
Sir, in this question, there is n is equal to 2 means if means sir, can I speak in Hindi?
Yeah. You can speak in Hindi.
सर माने यहाँ पे सर मतलब जितना कायरल सेंटर रहेगा उतना ही एनांशियोमर रहेगा क्या सर?
नहीं, एनांशियोमर मैंने बोला ना, ये फॉर्मूला है, ठीक है। यहाँ पे जो देखो, यहाँ पे हम लोग दो इक्वल हिस्से में इसको बांट सकते हैं, राइट? इफ वी say imaginary line, this is dividing the molecule into two equal halves, means two सेम हिस्से में। तो एनांशियोमर का फॉर्मूला है ये 2 to the power n minus 1. So n equals to here 2. So 2 minus 1, 2 to the power 1 equals to 2. Means two isomers are, two enantiomers are possible in this case.
ओके सर, थैंक यू सर।
समझ में आ रहा है?
यस सर।
ओके, कोई डाउट हो तो बताना प्लीज।
ओके सर।
इक्वल हाफ्स के ये दोनों इक्वल हाफ्स के लिए है, और ये दोनों जो है अगर इक्वल हाफ में डिवाइड हो जाता है देन इट इज द फॉर्मूला, राइट? And if it is not divided into equal halves, then it is 2 raised to power n only.
Yes, absolutely.
This 2 raised to power n is optically active or total?
Obviously optically active. If it is cannot
Only
be
optically
divided
active.
into two equal halves, then it is always optically active.
Okay.
Okay, so can we move to the next question?
Yes, sir, yes.
Okay, it is very easy. So what is the answer? कोई बताओ, somebody else, whoever is not responding, somebody. Okay, बताओ कौन सा सही आंसर, which is the right answer? Anybody?
Flying wedge होंगे ना, first two तो they are.
Yes, first two are the flying wedge, as some bonds are above the plane and some are below the plane. So this is flying wedge, first two. Then third one is this one.
Fisher and Sawhorse.
And last one is Shawhorse. Anybody has any doubt?
No, sir.
Okay. Okay, so which of the following compound is are chiral? So which one is chiral? Okay, so let's discuss according to the compound. Okay, that I think that will help you, right? So tell me if this compound is optically active or inactive, chiral or achiral?
Chiral.
Sorry.
Yes,
sorry.
Please. Yes, Sobik, bolo beta. Sorry. Sir, in this case, bromine and hydrogen is attached to this carbon, and rest are same. Both carbons are in the same environment. That's why first one is optically inactive.
So how can you explain why it is optically inactive? Means
Because
what is
it
the
has no
element of
chiral
symmetry?
carbon.
So there is a plane of symmetry there.
Yes,
Yes,
absolutely.
yes.
There is a
There is a
plane of
plane of
symmetry. According to this plane, there is, if we say, there is a plane of symmetry which is dividing the
Yes,
compound
sir.
into two equal halves. Okay, so whenever there is a plane of symmetry, center of symmetry, that compound is what?
optically inactive.
Achiral, optically inactive compound. Okay, so in case of compound 3, what is the logic?
It has also a plane of symmetry.
Yes, it has also, according to this one, right? This is the axis, means plane of symmetry, right?
Sir, I have a doubt in
Yes,
it.
yes, sure.
When you're considering the plane of symmetry, as the bone stones are above the plane,
Mm.
so we have to consider that also. Means that is, two bones are away from the observer. Is they can be in same plane?
Yes, if they are in the below also, then also it is optically inactive compound.
If
Okay,
one
that
is above the plane, other is below the plane, then
Yes,
okay,
then
then
also,
even then there is a plane of symmetry, right?
yes, then also there is a plane of symmetry.
And what
See,
about it has center of symmetry as well?
center of symmetry, if it has one is above the plane and one is below the plane, then it may has the center of symmetry. Like in this case, here we don't have center of symmetry. See, the two methyl groups are above the plane. So if we come, if we cannot be joined through a imaginary line, so there is no center of symmetry.
If we put a point in the center,
Yes,
then they are at the equal distance, is it?
no, it is not. If we connect a line through the center, it will go the downward, right? So it is downward, there has to be a methyl group.
Okay.
Okay, so here it is not.
Okay, thank you.
So what is the case of the compound 4?
So the compound 4 has also plane of symmetry
Yes,
along the accumulated carbon bond.
yes, yes. As these two groups are same, so it has the plane of the symmetry. So it is also optically inactive, right?
Sir, I had a doubt in this.
Yes.
So in these alleles, actually, there was something in the video where they are saying that the two double bonds are perpendicular to each other. Can you show in this particular compound how they are perpendicular to each other?
Actually, then we have to go to the bonding interaction.
May I explain, sir?
Yes, yes, sure.
Actually, middle carbon if on the left side there is a px, p orbital is used is px, and on the other side it is py. So it is actually like. May I share my screen? If you,
Uh,
if
I am
you
showing you. You just
oh
explain. I
yes, yes,
am
yes.
drawing it.
That's it. That's it.
Okay.
Right, sir.
So whoever asked the question, please consider here. This is the sp hybridized carbon, right?
Yes, sir.
Okay, and it is sp2 hybridized. There are two groups are there, right?
Yes, sir.
So here there is a pi overlap, right?
Yes, sir.
And
Yes, sir.
we know that p orbitals, px, py, pz are perpendicular to each other. We know.
Yes,
And
sir.
there is some, and this is this interaction. This is the perpendicular to that this p axis. So there is some deformation in my drawing. Okay,
It's
so
okay, sir.
consider that this p orbital, this bonding is perpendicular to that this pi orbital, pi bonding. Okay, so in
Yes, sir.
this way the two double bonds are perpendicular to each other.
And sir, the substituent groups on both ends of the first and the third carbon, will they be in the plane of the paper or like perpendicular to the two
No,
bonds?
they are not. They are, as we can see that two carbons. These two bonds are perpendicular to each other. So
Yeah.
So they are also perpendicular to each other.
Okay, okay.
Okay, these are on the plane of the paper, and as we can see from this structure, this is the below the plane, this is above the plane, and these two methyl groups are on the plane of the paper. So
Okay, okay. Yes,
this
sir.
generates our axial chirality. Okay, that is why the alene molecules are some substituted allenes are some chiral axis, and they are optically active compound.
Yes, sir. It's clear.
Okay, so here our compound 2, that is the only optically active compound. Okay, any doubt, anybody?
Sir, for the it is only C2 axis, right?
I cannot hear you properly. Hello.
Hello, sir. Am I audible? Hello.
Yes, yes, you are audible.
Yes, for the compound 2,
Hmm.
there is only a C2 axis, right?
There is only a
C2 axis.
To access.
there is
Only a C2 axis, he said. C2.
no, there is. How can you say that C2 axis is there? Tell me. Can you how do you draw the C2 axis? Here the substituents are different. See, here is bromine and here is methyl. So how can you draw that C2 axis?
He has only doubt. You can.
Okay, no, it is only has a C1 axis. No C2 is there. If it has the same group, like here methyl, here is also methyl, right? Then we can say that there is a C2 axis is there.
Yes, sir. Yes, sir. Yes, sir.
Okay,
I understand.
we will discuss in the next question. We have another same kind of problem. We will discuss. Okay. Can we move to the next question?
Yes, sir.
Yes, sir. Yes, yes.
Okay. Okay. This is the question. Have you solved
Yes.
this math?
This is this is the
Okay.
Yes,
easiest
sir.
one.
What is the answer?
3:7.
3:7. Okay. Have you? I hope you have know the formula. Optical purity equals to, yeah, I have written also. Have anybody has any doubt?
No, sir.
Okay, if we put the formula here, it is 40%. If we solve the equation, we will get by negative by positive equals to that 3:7, right? Okay.
I have not used the formula. It's just saying there is
Just
excess,
yes, just seeing the concept.
excess
Okay, that is
40%.
also okay.
So 60% left.
Ha ha
So
ha.
out of 60, 30 plus here. So 40
Yes,
plus
yes,
30,
that is very
70.
obvious from the it is very easy question. So whenever you
Yes,
have some more complicated, then you have
yes.
to put
Then
the
we
formula.
can use it. Yes, sir.
Okay. Anybody has any doubt?
No, sir.
Okay.
No, sir.
Okay. Okay, so someone is asking me regarding how to convert, right?
Yes,
If
sir.
we have more than one carbon, chiral carbon, then how to do the conversion, right? Okay, so here it is, which in which projection formula it is in the question? Flying wedge, right?
Yes.
Okay, so from flying wedge to Fisher, when you convert, just look at very carefully. We have drawn this bond. Okay, this is the axis of that molecule. We have drawn the this part. Okay, this part. So two carbons are there. So here we are considering this one as the upper one and this one is the lower one. Okay, so in case of upper one, from which side we are downgrading the group, means this is the hydrogen, we are writing it hydrogen. So from the left side we are taking down the hydrogen, and the above the group will be gone to the site where we have taken down that group. Okay,
Sir, can you explain this once more? I didn't.
Yes, yes, yes. So consider this chiral carbon, okay, this one, and we are drawing this in this one, right? So can you see hydrogen is which side of this bond, right or left?
The right side. Means
No,
we are looking
Left
from the
side.
above.
no, just take from the front. No such complicated vision we have to do.
Then
Sir,
it is
left
left.
side.
Yes, it is in the left side, right?
Okay.
So from which side, can you see that this is the above the plane and this is the below the plane, and this
Yes.
is the plane of the paper. So
Okay.
from which side we are taking the plane of the paper group, means in Fisher projection we know that the plane of the paper, the group in the plane of the paper are have to put in the vertical group. So from left we have taken the hydrogen in the above, and we will put the above the group, that is CH3, in the left one. So from which side we are taking the plane of the paper in the main bond, we will put the above the group in that direction.
Okay. Next.
Okay, so down one, you just tell which one. I have put chloro here because chloro is in the plane of the paper. So here, which group will go here in the place of chloro?
So fluorine.
No, just look carefully. From which side we are taking down, the above the group will go to the that direction. That is the CO2 CH3.
Oh, okay, okay, yes, sir.
And here, which one group will go?
Fluorine.
Sorry, loud.
Fluorine, sir. But, just to repeat, sir, I didn't understand.
Okay, so let me delete this one.
Devarkonda, sir, please turn off your mic. Devarkonda, sir, please turn off your mic.
అది లేదు కదా నాకు అవసరం కదా.
Aniket, sir, please turn off the mic.
సౌండ్ తగ్గించి క్లాస్ అవుతుంది ఇక్కడ.
Thank you, sir.
Okay, no? Okay, so let's start from the beginning. Okay, so in Fisher projection we see this kind of structure. Okay, so here we are considering this carbon. Okay, so this carbon is this one, right? So I am saying that the plane, the group which is at the plane of the paper, we will put that in the vertical position.
Okay, hydrogen and chlorine.
Yes, hydrogen and chlorine. One by one we are going. First consider in the this center only. Okay. So
Okay.
hydrogen is put in the vertical position. And now what I am saying, from which direction we are taking hydrogen to the vertical group, we will put the above the plane group on that direction. So which one here is the above the group?
CH3.
CH3. So here we will put
Okay,
CH3.
okay, got
in
it,
that
got it,
direction.
sir.
Okay.
Okay, right side. So we put CH3 on the right side.
Yes. And now tell me which one, which
Chlorine
will
on
go
left side. So we put
here. What will write
CO
here in the right side?
CO2
CO2 N.
CH3.
Exactly.
Okay, thank you so much, sir.
Exactly. Okay, so this is the Fisher projection formula of this flying wedge image. So it is
Sir, this holds true for single chiral center molecules as well.
yes, every chiral center molecule. You can
Okay.
you can practice in, if you find any such problem, you can practice in yourself, and you can ask if any face any kind of difficulty, you can ask me in the next session. Okay.
Okay, okay, yes, sir. Thank you, sir.
Okay. Okay. Just
Sir, shall I speak, sir? Hello?
Yes, yes,
Sir, 1 minute, shall I speak to you, sir?
yes, yes, sure.
Sir, it is better for you to construct a model with the Prentisol molecular model kit, and then you can say one thing, sir. It is very easy to write down from the this is the flying wedge. From the flying wedge directly you can convert into the Fisher projection like this, sir. See, you have front carbon here is in the inverted Y shape, and the rear carbon in the Y shape, and you know that HCl is in the plane of the paper. So one H should be written on the top and the Cl should be on the bottom. And because you have an inverted Y, you just reverse the order. Right hand side group right in the left hand side, left
Yes,
hand
yes.
side group right in the right
Actually,
hand side.
here I am
Similarly,
explaining.
once you have a Y shape, that just write the groups as it is. Right, left. Then it will
Yes,
be very easy, sir.
that yes, that we can do. I am just saying that if it is complicated any kind of structure, then what is the basic concept how we can convert this one? Okay.
I think it is better once you show the molecular model with this type of Fisher, so that all the students, all the participants will write the structures without any confusion.
Okay. So
So this
here,
is, see, directly the flying wedge should be converted into the Fisher directly, just by keeping in mind that whenever we have inverted Y shape, just reverse the groups, and whenever you have Y shape, just write the groups as it is. That
yes,
concept will be very helpful for all the participants, so that they can write the directly is from flying wedge to Sahos Fisher, they can write very easily.
yes, yes. Sure. So is this structure matching with any in the option?
No, sir.
No. So we have to rearrange it.
Then
Like,
then we have to use the Fisher rule that we have to rotate one carbon either in the clockwise direction or in the anti-clockwise direction, so
we
that there will not
now
be any change in the configuration.
now we can see here that here CH3 in the vertical position. See CH3 and CO2 CH3. So we can move this according to the clockwise. See, if we see the clockwise rotation, then we will change the three groups in clockwise direction, right? So here it will come CH3, here it is come hydrogen, and here it is come OH, right?
Okay.
Okay. So here, which direction we have to change the groups here in this carbon?
In the opposite side?
Why opposite side? The
Sir,
Whenever,
CO2
again
and
clockwise.
again clockwise. Absolutely.
okay,
Here, if we rotate the
clockwise.
clockwise rotation, the CO2 Me will come here, the
This is
fluoro will come here, and fluoro will come here. So in Fisher projection, there is rule that even now a number of the exchange means we have exchange three groups, right? CH3, hydrogen, and OH. It is permissible. But if we exchange only these two groups like CH3 and hydrogen and OH, this is not permissible. Okay, we have to exchange the odd number of the groups. It is permissible in the Fisher projection formula. Okay, is that right? Clear?
Yes, sir.
Okay.
Now,
Yes.
Devarakonda sir, please explain once again what you said. We didn't
Sir,
understand.
shall I clarify, sir? Hello,
Yes, yes,
participants,
please.
shall I clarify, sir?
Yes,
Clarify to
yes,
Yes,
you,
yes.
sure, sure.
sir. One chiral carbon. See, there are 4 groups in the chiral center, right?
Okay.
So one group is fixed, and the remaining 3 groups are rotated either in the clockwise direction or in the
Yes, yes,
anti-clockwise direction. Nothing
yes.
will happen to the configuration.
Mm-hmm.
So you fix the top carbon, and then rotate the remaining 3 groups in the bottom carbon either in the clockwise or anti-clockwise direction.
Yes, I am
Similarly,
saying.
fix the bottom carbon and rotate the top carbon either in the clockwise or anti-clockwise direction, and see whether you are getting the option in the given options or not.
Yes, I am
Sir, that
saying
is
this.
what Aniket sir did. Like, same
I
thing.
have said the same thing I have said. We cannot
So
change.
that is one of the wonderful rule in the Fisher projection.
Okay.
We cannot change any two groups. We have to change any three groups to keep the configuration intact. Okay.
Okay.
Okay. So here, what is the question answer?
The statement is correct for the following. This compound has
Tell me what kind of uh, which element of symmetry is present here?
Sir, C2 is evident, but alternating axis of symmetry, how to find out, I'm not very sure.
Yes. How many C2s are there? One is this one. Okay. If we rotate in this direction, then the C2 means 180 degree, then it will give the same direction, right? How many C2 it has? This compound has?
One in
One
the
I have drawn,
particular.
and how many other?
Uh,
Have you imagined the
C4
structure?
maybe.
These two CH3 are on the plane of the paper, and
Okay.
these two CH3, one is below the plane of the paper, and this one is above the plane of the paper.
No idea, sir. Please explain.
Okay, so this is the molecular axis of symmetry. This is the main C2 axis, principal axis of the molecule. So it is the C2, and the other two C2s are going through the perpendicular to this molecular axis. Okay, this is the perpendicular. If we rotate this molecule according to this axis, then it will give the same molecule. Okay. So, okay, this is not question here how many C2 we have. Then other than C2, if do we have something?
Sir, the other two dotted lines that you've drawn as C2, can you explain how it is C2? Because once we turn it around in that way, I don't think it's still the same molecule.
Okay. So if we suppose there is an imaginary line here, this one. Okay. So if we rotate around this line, okay, so this carbon will go to the this one, this side.
Yes, sir. Sir, my doubt is only in the, end carbons, like the first and the third one. If you see on one side it is in the plane of the paper and on another side it is perpendicular to the plane of paper. After rotating, it will get reversed, right? It will not be the same molecule.
Yes. So okay, let's continue our discussion. We will discuss this later. So what kind of another symmetry is had? Can you explain? What any other element of symmetry it has or not?
Plane of symmetry, sir.
No, from these options. See here
Options. Okay.
S4
Because
or S2.
I think is this C4. If we rotate it by 90 degree along the
You know, alter means that S4. What is S4 or S2? What is S
yes,
operation?
C4 and sigma, sir.
This is the combination of two operation like
Yes, C4 and
rotation.
sigma, right?
Yes, rotation and reflection.
Yes.
Exactly. Okay. So let's try to explain what other kind of molecular symmetries has. Okay.
Yes.
So if we consider a mirror plane here, right? Right? This is the mirror image of this one. Hello?
Yes, sir. Yes, sir.
Yes? So
Yes,
this
sir.
is the reflection operation we have done. Right?
Yes, sir.
So now if we rotate according to this axis, how much we have to rotate to go back to the original its position?
360 degree.
No, not
90.
360 degree, exactly 90 degree. See, this is the above the plane of the paper and this is below the plane of the paper. So if we rotate it according to 90 degree, then it will
It will
come
be
to
a
the
plane of the
plane of
paper.
the paper, right?
Yes.
And 90 degrees equivalent to 360 by 94, that is C4, right? So this is the sigma operation and it is the C4 operation. So combining these two, we are giving it as the S4, right? Is this clear?
Sir, the C4 sigma and sigma into C4, they are equal.
Yes, they are equal.
Okay.
If we rotate at first, okay, you are saying that at first can we do the rotation and then reflection, right?
Hmm.
They are same operation. Okay, just I was just trying to check whether you can answer this or not. So is that clear?
Yes,
Yes,
sir.
sir. Yes.
Okay. So what is this answer?
Option the best describe the relation between these two structures. It is C4 epimer.
Yes, it is C4 epimer. It is written here. So you know
How
the
could it?
epimer. What is
It's
epimer?
means it
In
is
one carbon is attached with two different groups on the different sides. Like
Yes.
in fourth carbon, OH is on right side in the first part, and
Mm.
it is in of the left side in second part.
Left and the second part. Okay. So here I have written here the number of epimers. Okay. Epimers have the opposite configuration at only one stereogenic center out of at least two. Okay. So only one stereogenic center, the configuration is different. Okay. So here it is number one. Like CHO is is number one, first priority. Then it is two. Then it is three carbon. Then it is four carbon. It is five carbon. So in this carbon, you can see that rest of the configurations are same, right? But in
yes.
case of this carbon, it is different. Okay, so it is called the C4 epimers. So only at the C4 carbon, the configuration of the stereo center is different, right? Is that clear?
Yes, sir.
Yes, sir.
Okay. So here, which is very interesting question, how many chirotopic and stereogenic carbons in the molecule? Tell me how many. You have to explain them.
This Cairo topic is not covered in the lecture actually.
Chirotopic is not covered in the lecture.
Yes,
Okay.
stereogenic center, stereogenic carbon, we know, I know means, but
Okay.
Cairo topic that is not covered in the
Okay.
during the
Stereogenic,
lecture.
everybody knows. I have also told that what is stereogenic. Stereogenic, everybody knows what is stereogenic center.
Yes,
Chiral
sir.
center is
Sorry. Yes, please.
the stereogenic is same as
Stereogenic is same as.
chiral center.
No, sir. Chiral centers are a special case of stereogenic centers.
Yes. The concept is somehow different between two groups. Okay. So chirotopic is the molecule when we say that when a molecule is the chiral environment. Okay. So we will let's discuss with the example. Okay. Okay, how many stereo centers are there in the molecule which I have drawn?
3.
3, absolutely. Then you tell me what is the status of this center with respect to chirotopic and stereogenic. Is this stereogenic?
Yes, sir.
Yes. What I have told earlier in the class, if we change the position of the two groups like OH and H, see here we change here OH and this side H, then the whole configuration of the molecule is changed. This is a different stereoisomer, right? Right?
Yes, sir.
Okay, is this chirotopic?
That I don't know.
Sir,
Okay,
maybe yes, sir.
yes, it is
Yes,
yes.
sir. It's chirotopic.
Because chirotopic is the when we will say atom or a group chirotopic when it is in the chiral environment. See here, no such sigma plane or point of inversion is there in that molecule, right? So it is in the chirotopic. Like in lactic acid, like if any, like a molecule.
That means, sir, I'm sorry to interrupt. I think second one is not chirotopic then.
Let me come. We will discuss. Okay.
Okay.
Okay, so this is the molecule. Carbon is attached to the 4 different groups. So is this molecule chirotopic? Is this carbon center?
Yes, sir.
Yes, this is chirotopic. But if we change the B group with D group, will it remain as chirotopic?
No,
No,
sir.
sir.
No, because the groups are two same. A sigma plane can pass through this one, and this is in the achiral environment. This whole plane. So this C carbon is no more in the chirotopic environment, right?
Yes, sir.
So here now coming to the next carbon, you tell whether it is chirotopic or stereogenic. What is the answer? Is this stereogenic?
Yes, sir.
How can you explain that it is stereogenic?
Sir, if we reverse the two groups H and OH, we will get a.
Exactly. If we reverse the two group, this hydrogen in the left side and OH in the right side, then it is a complete different stereoisomer, right?
Yes, sir.
Okay, so it is stereogenic. Is this chirotopic? Is this center?
No, sir,
No,
it is
no.
achirotopic.
Yes, there is a sigma plane in the molecule, right? Right? Can you
Yes, sir.
got it? What I am trying to explain?
Yes, sir. Yes.
Yes,
Okay,
sir.
so it is not chirotopic. So someone is saying at first that chirotopic and stereogenic are the same. Is this same? It is not achirotopic, but it is stereogenic, right?
Yes, sir.
Okay, so
That means for a chirotopic carbon, it should not have any plane of symmetry present there.
no, the environment should be chiral. Then only we can say it a chirotopic atom.
Okay,
The
sir.
site symmetry of that group or atom should be chiral. Okay. Okay, now tell me regarding the third carbon, this one, is this stereogenic
Yes, sir.
Yes, sir.
and chirotopic?
Yes, sir.
Yes, sir.
So is this clear, the concept of stereogenic and chirotopic?
Yes, sir.
Sir, one doubt.
Yes.
Sir, if a molecule has any particular chirotropic center, does it automatically become optically inactive? Because it has a plane of symmetry, right?
Sorry, I did not get your question.
Sir, if one center is a chirotropic, that means it has some plane of symmetry.
Some
So,
plane of symmetry. Yes, yes.
so the entire molecule automatically becomes optically inactive.
Hmm. This is the meso compound. As you can see that meso compound, when we say that some part of the molecule cancels the optical rotation of the other part of the compound.
Okay,
Okay.
okay,
So
sir.
this compound is optically inactive, and we call this center as the pseudo-asymmetric center. This middle carbon, we will call it as the pseudo-asymmetric center.
Okay, sir. Yes, sir.
Okay. Okay. Now coming to our original question, what is the status of this one? Tell me.
So it's stereogenic as well as stereotopic.
Okay, stereogenic as well as chirotopic. And the next one, this one.
It is true for all.
Okay, just coming point by point. Here it
Yes.
is stereogenic as well as chirotopic, right?
Yes.
Okay. So, and this one,
Stereotopic, stereogenic both.
chirotopic, stereogenic both.
And the next
And the same is also goes for the next one, right?
Yes, sir.
That means if number are odd, then there is one stereogenic center, and that one is not chirotopic.
Yes. Here, if here there is a carbon, if
Yes.
it is a carbon, 5 carbon is there, then this center will be what?
so it is the stereogenic center, but not a chirotopic center.
But achirotopic,
Yes, sir.
right? Okay, so hope the concept of stereogenic and chirotopic is clear. Is this clear?
Yes, sir.
Okay.
Yes, sir. Clear.
Okay. And now this, have you solved this? Have you solved this?
Yes, sir.
What is the answer?
The answer is 0.8 plus 0.95. That is given here, but actually alpha
0.49.
alpha we have, and 0.1 gram per 2 ml, so 0.1 by 2, and 1 decimeter into 1.
So here it is simply but putting in the formula that it is rotation is given 18.9 degree equals to, here we have to determine, and here it is 0.1 by 2 into 1, right? Right?
Yes, sir. Yes.
Okay, so if we solve this, we will get A equals to this one, right? Okay, so all 12 questions are solved for day. Anything else you want to discuss or any doubt you have?
Sir, it is very nice session. Every Friday you are here with us.
Yes, every Friday for
It's
the next
really
2 months.
Means great help, and really we are enjoying your class.
Okay, really?
Yes.
Thank you,
It's,
thank you. I
it's
will
great
also
to
be
meet you.
very happy if I can help somebody in any respect. It will be I will be very happy from my side. Anybody else wants to say anything? Anybody else?
Sir, 1 minute, sir.
Yes.
Sir, it is better you use the molecular model, sir, while explaining the answers. That will be very bad. But that will be
Molecular
a very good
model means
benefit to all the participants.
any software you are saying, or I
No,
didn't get.
direct molecular models, sir. Prentice or molecular models will be there, no? So whenever you're doing any conversion, right from one Fisher to Sawhorse or any other thing, better to use the molecular model.
Molecular model means any kind of
This one, sir, Prentice or molecular model kit will be there, no? Ball and stick model.
okay, means okay.
That is better. Then all the participants they'll get benefit out of that. The clear
Okay,
picture will be there. Clear picture will be there if we use the
then
molecular.
I have to manage. I don't have that model. Okay, I will try to.
Devendra sir, actually you are right, but actually we are here. I think whenever we are sitting in the exam hall, at that time we don't have those. For understanding, it's okay, but I think we are practice for the exam.
Sir, you will get a better visualization in your mind once you have the molecular model and visualize that. Then when you sit in the examination, you can do without the molecular model.
Actually, then
I
the
agree,
main
sir.
problem is
You are
we are here in the online mode, right? If we have the classroom kind of thing, then it is very helpful to visualize the things very.
Yeah, sir, you are using the PowerPoint now, sir.
Yes.
You can switch on the video, sir. If you switch on the video,
Yes,
just show the
that
molecular model and you
that
can do
I
it.
can that I
Okay,
can show.
okay.
Okay, I will try to manage.
No,
I don't have actually.
stereochemistry always will be helpful only when you get the molecular visualization, sir. Otherwise, everything will be just only
Yes,
hypothetical. Otherwise.
yes.
But we enjoyed the class. They were going to, sir, no doubt he has limited resources, but
Okay, no problem, sir. That's very
he
good.
has explained the things very nicely and
Yes, that
really
I
it is
agree. I
fun.
agree. I
Means
agree, sir. That's true.
something is better than nothing. That is
No, no.
the
My
word I
my
like.
my intention is not pointing out. My intention
Yes,
is I'm just telling that all the participants will be more benefited
I
if
agree,
at
Sir,
any
with
place
you.
wherever it is required, better to show the molecular model.
Okay,
That's it. Not
anybody
more than
wants
that.
to put any suggestion or anything you will be beneficial, anything you want to add, anything, any difficulties you have faced in the first session, if anybody wants to add something.
Sir means are very cool. Sir, who is teaching us, is very cool, and I'm understanding each and everything, whatever he taught us in the
Okay,
first week.
okay.
But some topics, like say, you have explained those two chiral carbon
Hmm.
means to conversion,
Hmm.
chirotopic, that are not covered in the means lectures. That is only concern. Rest is going very nicely.
Yes, actually, in the limited period of time, it is very difficult to explain all the things, right? All the things in a very limited period of time. But I am
Yeah.
trying to help you guys if you face any kind of problem, any difficulties. You will practice in your home. Anything you require, you can ask me in the next session. I will try to support you as per my knowledge and capabilities.
Thank you so much.
Okay.
Yes, sir.
So now let's meet in the next Friday. You will just go through the assignment 2 and we
Yes.
will try to solve the assignment 2 in the next session. Right?
Okay. Okay, sir. Thank you so much.
Okay, that's it for today. Thank you everybody for attending the session. Thank you.
Okay, sir. Yes, देवरकोंडा सर अब तो अभी सर तो चले गए